Hello, everybody, and welcome to today's introduction and overview session of the certificate program in Python for Finance with the core topics of algorithmic trading, computational finance, and asset management. My name is Yves. I'm CEO and founder of the Python Quants and the AI Machine, and I am your program director. It's always a pretty exciting moment to kick off a new cohort for our certificate program, in particular when it is at the beginning of a new year. So the excitement feels like twice as high. I have, as usual, and it's now tradition for this intro and overview session, quite a few slides that are intended to give you really an overview, a feel, framework, a red line for the certificate program, because over the years we have grown the content tremendously, and in the meantime I think it's kind of safe to say that we have almost reached a point in terms of content where you could compare what we offer you in this program with a master's degree in this topic. I'm not aware of a master's degree in Python for Finance, so we are specialized. We focus on this particular topic, which has become so important in the financial industry, and you can be assured you will learn tremendously important skills for this particular area these days. And without further ado, let me get started with the slide deck. Here, the agenda. You see quite a few points, and as we go, I said the program is growing. We just recently added a new basics class, as we call them. So we now have 3, like mathematics basics, given the demand, relatively high demand that we had in the past, where people ask for a little refresher with regard to the math basics that are required for the program. We have just added in the last cohort Python for Finance basics, which is kind of like a complementary class with regard to what we cover in the other different more focused classes. And crypto basics also one of last year's addition to the program. I will have also a couple of examples that will at least whet your appetite. Today for sure is not a training session. It's not intended to teach you anything. It's just, again, to provide you an overview and maybe, again, whet your appetite for things to come. You see, the agenda is pretty long. We are going through all the major classes, and I cover also some organizational topics and also some, let's say, guiding principles, for example, so that you are ready after the session to get to your deep dive into the content. Quick introduction. We're the Python Quants. We focus indeed on Python for Finance, provide training such as the one here, certificate program in Python for Finance. We run platforms such as the Quant platform. We have open source packages. I've written a bunch of books. Of course, you get a certification if you are successful with the program. We run events, thankfully these days, again, on-site and in person. And we also provide here and there services, development or consulting services for institutions on a global basis. We've also another kind of project, which is our proprietary trading platform, which is called the AI Machine. And this is developed and maintained by a team in India and Hyderabad, and it is meant to provide a, let's say, unified framework to do AI-powered Python-based algorithmic trading. Here, if you're interested in a bit more of my personal background for you as a reference to read through, I'm not going through the details. You have it all in this slide deck. My most recent book is basically the introductory book in the series of my 6 books about the topic. Financial Theory of Python, a gentle introduction, as delegates of our certificate program of the Platinum package, as we like to call it in the past. Primarily, you get access to the PDF versions of these books, and that, again, is the last one, which was published in 2021. It's the introductory one. Then the next one, in line, I would say, in the sequence, we want to study thoroughly, is Python for Finance, which came out in 2018 as a second edition, and which has been translated into multiple languages like Japanese, Korean, Chinese, and a few more. But it has become something like a reference book for the topic itself, which I'm obviously pretty proud of. Python for algorithmic trading, which is obviously also one of the core topics, and which has become at least part of the core of basically everything that we do in the program, is artificial intelligence in finance. So AI is something that will be used, let's say, in trading, but also in asset management, etc. So it's nothing that is exotic or so special anymore. It has become an integral part of so many domains and subdomains in finance, in particular Python for finance, that it seems like indispensable. And in the age of, let's say, ChatGPT, etc., AI has become now a common expression, even used at, let's say, at the pub, at the bar, and back home, maybe at the dinner table, etc. pp. So AI is there, and we cannot think of a future, let's say, where AI doesn't play a very prominent role in basically everything that we do. A little bit more on the traditional side in finance are these two books, which relate to quantitative topics in finance, such as option pricing, trading, for example, here of listed volatility and variance derivatives, obviously a very important asset class. These books do not teach Python. They basically use Python for quantitative financial applications. To the program, I promised, it has grown. The standard pace for the single cohorts, for the live cohorts, is 16 weeks. So 12 weeks of formal study schedule, right? And then 4 weeks for practical applications, for practical exercises, which then hopefully lead to a successful final project. And yeah, you see there's quite a bit to cover, maybe a bit too much for a formal 12-week study program. But since everybody who has signed up to our certificate program has indefinite access to their resources, there is no need to rush, no need to feel afraid of the mass of content that you find on our Quant platform. You can study 4 months, you can study 12 months, or if you like many of our delegates and students have done in the past, also over multiple years. In part also obviously benefiting from additional classes and additional content, or maybe updated content, for example, that has been added to the program, right? If you still wonder why you should do the program, why you should study diligently Python for finance, yeah, here's a recent article of eFinancial Careers. If you want a banking job now, you need to code in Python. Down there, one quote, one screenshot. Therefore, if you're trying to get into banking now, Python is the skill that's needed. Python will get you a job across the banking industry in anything from sales and trading to portfolio management or risk. It is the one skill that really differentiates applicants in the recruitment process. And I'm convinced that this is not only true for banking, that's true for trading. If you want to go on the buy side, right? If you want to work for asset managers, for hedge funds, or for insurance companies, or other financial entities, that's really the way to go. Even if it's related to other asset classes like crypto, for example, Python always will be an asset that you can leverage no matter what type of financial job you're targeting. At least if there is a little bit of quant stuff in that job, you are already on a good path if you study Python for finance diligently. I've mentioned our Quant platform a couple of times, so I want to get started here with it. I will show it to you later on. It is your central resource. So basically everything that was kind of like in numbers on the previous slide, like 2,500 plus pages, like 25,000 lines of code, which are basically quite a few more, but I like these numbers somehow, so I stick to them. They're all found on the Quant platform, but this doesn't mean that you have kind of like a login where you can only use, for example, the code that Jupyter Notebooks on a Quant platform. But this is what we offer you: a central repository with all the resources, such as videos, such as the text that are relevant, such as additional resources in the form of gists or slide decks or whatever, the Jupyter Notebooks, the code files, the everything, right? Including the user forum and a bit more on the Quant platform. Everybody of you signed up to our program should have access. to the quant platform, where you find everything, hopefully, kind of easily, that I'm going to show you, that I'm going to discuss afterwards, right? So that's the central resource. You basically, to get started, you don't need anything else, not even let's say a local Python installation. You can get started even without that, and I pointed this out already in the first weekly orientation email. Now to the classes. Based on, I can say, high demand in the past, we have recently added more basics classes, as we call them, because many people are trying to change jobs, or they might be working, let's say, in the industry for a longer while, and the mathematics, for example, have become a little bit rusty, and they were looking for refreshers based on Python. So this is what we added recently. So a class where we review fundamental mathematical concepts based on simple Python code. So it's not about the theory in and of itself. There's quite a bit of theory, for example, in this particular class that we cover, but of course it is Python for finance, and we use Python also to review and teach mathematical concepts, right? So everything is targeted towards improving your Python skills. And the basics class, they usually go at a slightly slower pace, and the code is usually a little bit more simple as compared to what you might find in other classes, so that you can get started, maybe also reviewing these a little bit more quickly than maybe might be the case for the other classes, where I know from experience that some people say, well, oh, this particular module, for example, was something that I didn't understand at the first go, but after the third one, I mastered it. Here, I would suppose that this is more easy to understand, and also provides you a ton of opportunity to exercise the skills themselves, right? Python for finance basics, that's another one that we just added in the last cohort. So here the focus is more indeed on the Python programming side, where we review idioms and major packages such as NumPy and Pandas, but we are not going into every single detail that you could cover in principle. So here the focus is really on the stuff that you will need 80 to 90% of the time, where we leave out the final 20 or 10%, where you would need to go that much deeper and that much broader, for example, to get the full coverage, so that you have like here a good foundation, and you will find many more details in the other classes which add on that. Therefore, when you read the description of this class, it's not a class that replaces other classes. It's more like something that you could use to get started a little bit more easily, a little bit more quickly, and then jump into the other class. You won't find, for example, math basics and PFF basics on the regular study plan, for example, really in the sense that they are complementary and not like something that replaces anything else that we do there. The same holds true for the, sorry, there was some mathematics basics which was mentioned there. The same holds true for crypto basics. This is a class that we started last year as well. So relatively new here in the whole program, and we might add to that in the future. So we keep this flexible, also depending on demand from the group of delegates. And this covers not really, let's say, Bitcoin trading, to name one particular area of interest from my experience, but rather the underlying technologies that are so relevant in the crypto space, right? Like hashing, encryption, and all these topics that have not been invented by Satoshi Nakamoto of Bitcoin, right? Many of these have been there already before, but have been used and combined in like a ingenious way to form what crypto today represents, right? So here we try to focus on the very basics, so that you get from ground up experience with the single pieces of technology that make up the ecosystem as of today. So finance with Python is now really a finance class, which is more or less based on the book Financial Theory with Python. But when I say something is based on the book, it usually means that the class was there first, then I was writing a book on top of that, and then the classes have been adjusted to reflect the reality of the book, because writing a book usually is a tremendous effort, but B, gives more clarity on a certain number of topics, on the structure, on the frame that you use to present the topics, the didactical approach. Therefore, both the teaching, the classes, as well as writing of the books, they reinforce and support each other. So here, finance is indeed now a major topic. You see here the book that I mentioned, on which this is now based on, with the caveat that I mentioned before. And here we go into very basic financial models and concepts, right? Like fundamental theory of asset pricing. I mean, the name is for a reason, fundamental theory. Static three-state economies, for example, where we cover incomplete markets, also a very important concept. Then we go generalize the models that we are dealing with in two dimensions. First, with regard to the number of states, and second, with regard to the number of points in time that we consider. This is what you see on the right-hand side, some visual representation in the form of simple trees of the economies that are covered there, right? So that's really about finance. But of course, as with the mathematics basics class, let's say, Python is here an integral part. You can think of it like a triangle where we use mathematics, where we build or model the financial concepts based on the mathematics, where we then implement the mathematical financial concepts based on Python. That's the idea, and you see here you have the text, also in the form of a PDF. There you have the videos with the resources, and then you have the code there as well. And this is usually the point that I want to stick to this approach, where I show for the first time the Quant platform. So base.pqp.io. I'm already logged in. Right here you see the latest videos. So this was the latest live session. It was in Python for Finance Basics 20. If we have, for example, now Python for Finance Basics 21, then you will see this here in the first spot. We have the three latest recordings of any kind of live session are presented up here. On the dashboard as well, you find latest forum posts here with regard to, for example, there was one question about technical indicators to be used with machine learning models to predict the markets, or here is something related to crypto concepts from the crypto world. Here, SHA-256 as one of the major hashing methods there to connect to an API, or here vectorized backtesting, right? So also the first four most recent posts, and then you can go down there as well, or you dive into the different boards of the user forum here, like Python for Financial Data Science or Finance with Python, the class from which I jumped off here, Python Computational Finance, DX Analytics, AI. You see here are the different boards. Quant platform is everything around the platform itself, meaning, for example, how can I do X, how can I do Y, or where do I find X, where can I find Y, etc. So that's the dashboard, and it gives you already an overview of the most important things. On the upper left-hand side here, where you see menu, the three bars, you see here are the books. This is something that comes with the Platinum package, or the most recent iteration of our certificate program only, where you get access to the 6 books, then the user forum, or what we call courses traditionally, and Finance with Python, Python for Finance, and Python for Algorithmic Trading. There are HTML texts on top of maybe the PDFs, and all the different training classes, where you see that's kind of like a pretty long list that you find here, plus JupyterLab. I'm not opening JupyterLab directly. I will do it from the training class, but I show you the resources now, where we have here finance with Python, for example. When I click on that, another tab opens. That's the text. That's a pre-version of the published text, where you see on the left-hand side a table of contents, where you can easily navigate. Let's say you're interested in RWA securities in this context. You can scroll down, you can navigate this whole file as you are used to with any kind of HTML page. Of course, this is kind of a pretty long HTML page, because this page alone later on became a book of roughly 200 pages, right? So that's the text which was on the screenshot, right? Then you have also here on the book side, right? Financial theory with Python. You need the password for that, which was sent and shared with your welcome email. So everybody who has signed up for the right program should have the password, because I know every once in a while I get questions, oh, this is password protect, what is the password? And the password is found in a passage in the welcome email, which has as a header, please read the following carefully. Right? So that's now the original version of the financial theory with Python book. Of course, different stylings, not HTML, but you can still navigate here. For example, here is a link, for example, chapter 5. If this is of interest, you can navigate there as well. But again, it's PDF versus HTML. That's kind of different. It also looks a little bit different. So that's the text. Not every class has such a text, but I think the names, they speak for themselves. So for example, Python for algorithmic trading is the basis for Python for algorithmic trading, right? Or for the computational finance part, you have list of volatility and variance derivatives, as well as derivatives analytics with Python, for example. But again, not for every class. Let's say Python for Excel, for example, doesn't have a book, but if you're interested in a book from the one who invented and authored Excel Wings, for example, what we cover, there is a book available on the market, but this is not written by us, this is written by Felix Zumstein, for example, since I'm now mentioning Excel Wings and Python for Excel. So then you have here in the, let me close that, you have in the trainings part, the different training classes, right? And there it is, finance with Python. As on the screenshot, you see here, this has 6 classes, 6 modules, I would say. We call this typically a class, and we have single modules, live sessions plus the resources make up one module, right? And when you want to get started with finance with Python, number 1, you can navigate there, or you see here, for example, you can open the slide deck that is used for that. I think this should be straightforward and clear, right? Where you get the slides that are used for this particular class and session, right? And you see here the Jupyter Notebook files. When I click on a Jupyter Notebook file, it takes a few seconds, and it's taking a little bit longer than you might used to, particularly when you start your first Jupyter Notebook or click on the first Jupyter Notebook, because this spawns a Docker container, and this takes a little bit of time because everybody gets their own Docker container, right? And after this single click now, you see the Jupyter Notebook file that is used at the very beginning. I can now, in this class, you see here the path. I can double click on the second one, get access to the second Jupyter Notebook, which, as I was saying, can be fully executed and used here on the Quant platform. And again, at this stage, you don't need really to have a local environment, although we get started from the beginning, also explaining setting up the environments on the different platforms such as Windows and Mac, etc. Right? If you want to change something, of course, you can execute this here, for example, with Shift Return, going step by step. Maybe you change something, right? Where you go here and change this to 10. Now you have changed the notebook. For those of you who have worked with Jupyter Notebook, you see that this is now not saved, right? When I would go here the menu way, save notebook, save all, this doesn't work. You see this is grayed out because we provide you with read-only copies, right? Only copies for reading, so that you will always have, no matter what you do, you will always have access to the original Jupyter Notebooks. If you want to, and that's the reason why I'm highlighting this here, if you want to save a copy, you should go to Save Notebook As. Then it shows you a pretty long path here, right? Trainings, finance with Python, etc. This is now the full path, and I can here go, for example, and simply delete the first part of the path, right? Maybe put a slash here or not, and then I can save it now. Now you see here the X cross, which indicates that it was saved with my change here. I changed from 1 to 10. And when I go to my root folder, right, you see here Finance with Python. This is what I've just saved, right? So with the current date, current time, but this is something that you need to be aware of. We provide you with read-only copies here. If you want to save your changes, there's no need to save the changes. Say, well, I was just trying out something. But if you want to save the changes, then you go to File, Save Notebook As, and then you need to adjust the file path to a directory, the root directory, or whatever folder you have created while you want to save your copies. Right? So that's basically the setup here on the Quant platform, where you have text, not always, but for many of the classes you have text, then you have the videos, plus some slide decks, plus the code and the resources, right? So I'm now going and shut down, because when I'm finished with everything, you don't need to do that, but it is usually nicer because it then stops Jupyter Lab from running, and if many people are on the Quant platform, this frees up a little bit of capacity, right? So that's the setup as a blueprint, which is basically the same for every class that we have. There are here and there are differences. I will highlight the differences when we go now through the rest of the class. So when you're done with it, you can either log out or simply close the tab here, and we can move on here to the other classes. Tools and skills, for example, is already the first exception. This class is a little bit different with regards to the way it presents things. What is the same? You see the topics here in overview is that you have videos plus resources, but the resources are to a large extent a little bit different, because here it's more intended to be done on the command line. I will illustrate this in a minute. Here, how to install Python. This is what I mentioned before. We teach this from the very beginning, Mac and Linux. The usage of Jupyter Notebook within Docker, for example, cloud usage. We start quite early with that. Basic Linux tools and shell basics throughout this whole class. Code editing with Vim. You might say, well, if I use VS Code, I use Sublime, I use X, Y, that, right? That's fine. But we teach at least basic usage of Vim, because you can use it on Windows, on Mac, on Linux, in the cloud, in a Docker container, basically everywhere. And this doesn't hold true for other editors that are usually used as desktop versions, right? So when we then combine Vim as an editor with Screen for session management and Q for logging, then we have what I call a lightweight tool chain. This can't do everything for you, but it will cover 80 or 90% of the use cases. And in some classes, you see how I would recommend using this. For example, when you code in the cloud in Python for algorithmic trading, say, and set up your trading infrastructure with logging, with monitoring, etc. in the cloud, then this little lightweight tool chain comes in pretty handy. Testing, Git version control, also packaging, documentation, and code hosting. So it's more on the infrastructure and software development side of this class. I put it here at the very beginning of the rest of the classes, so to say, after the very basic one, the basics classes and Finance with Python, because it can't hurt if you start early on learning maybe new skills, or maybe improving the skills that you have already in this context. Or you say, well, I'm a master with all the tools that you cover here, then you can skip that class as well. That's for sure. But I know for many of you, this will be at least a good review of some major tools that are used in other class, or that you can make use of, that you can leverage for your work. So we cover throughout mostly similar topics. So Jupyter Notebook, Jupyter Lab is something that we have as a milestone for setting up the infrastructure. We need, of course, a Python interpreter, and this can be hosted on a local desktop machine, or run within a Docker container, or we have it in a cloud instance. And here, actually, the cloud instances start at $5 per month. And when you follow this link, this is a referral link. I think these days you get $100 for free cloud usage when you sign up for the first time here with DigitalOcean. When you use that link, and you see here $5 per month, that's pretty long for 100, but I think the $100 they are valid as far as I can tell, but you should check for 2 months only. So you can run, let's say, 2 bigger droplets for 2 complete months there for free and see how it works out for you. So let me quickly show like the setup of the infrastructure, because I know for some of you this might be a big hurdle in the beginning, right? So I want to here, and this is nothing that you should now replicate really, right? Or try to follow along. That's not the intent here, but I have it at the beginning of the gist here on GitHub, where I have the resources for my later demos, right? Here for the certificate program, January 2023 cohort, our current starting cohort at the beginning of 2023. And here's one, and this is something that we teach as well in the tools and skills class, but I'm using it now here just as a way of showing how to set up an infrastructure from scratch. Again, this is shown in every detail in the classes, in the modules themselves. But for me here, running on my Mac Mini, I have, of course, Python installed. I have a couple of environments running there. So it's kind of difficult to start from scratch. But with the Docker container, it's pretty easy to start from scratch. So I run this command. It sets up a Docker container for me. Now I'm on my Mac hardware, but I'm on a Linux operating system. You see here the structure of the root directory, a couple of folders, etc. I am logged in here as root. You see root at cert, right? When I go to root, there is nothing in there, but one folder, and in the live folder there are my example files that I'm going to show you later on. Just that I have like access to my local folder and a few files in here. So one of the first things that you would typically do here is to update the package index. This is like kind of looking on your Windows machine, let's say, whether there are updates available, and then you're prompted, do you want to install the updates? Yes, and here I would need to do the upgrade. I put a Y flag here, and it will upgrade those packages that might be out of date. How long this takes depends on your connection and a little bit on your machine, and now I'm good to go. I don't have Python here, so this Docker container is kind of like a minimal installation, right? Let me increase this a little bit. You can afford to have this a little bit larger. No Python whatsoever there, and I'm going to use Miniconda, which is what we recommend. And I use one tool here, a little tool, wget, which allows me to retrieve remote files or files from any source on the web. I have installed this now, wget. You see here, missing URL. This command expects the URL where the file that I want to retrieve, be it a text file or an installer, is located. And in that sense, I now navigate to the Miniconda page. And on the Miniconda page, you find a bunch of installers. I focus here on the latest Miniconda installer links. And for my machine, I want to install on Linux. So that's the operating system. I want to install Miniconda 3, latest installer, right? And I need Arch here 64-bit because I'm running here on Apple Silicon, which has the Arc architecture. Therefore, I need this. If you are running on a different infrastructure, let's say I have here in my side another Apple machine which has an Intel processor, this would then be this installer. If you are doing the same exercise now on a Windows machine, you get it here, right? Or for Windows, I must say, for Windows, right? So for Windows container. So let me now copy the link address. Here you see it. I did a right click, copy link address. And this link address is what I can now put in after wget, right? Pretty long, therefore I copy it. I don't want to type it. This file is kind of long, but not too long, large. Let me see what it has, exactly 52 megs. So that's not large, but also not tiny. And I use this now to do the installation via bash. Here it prompts me a couple of times. I press enter to continue. Space, 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 space. From the last time, now I say yes, I agree to the license terms. I can live with the default target folder here, and we are already in the process of installing Python. This is a pretty efficient affair, and when I now say yes, it will change my bash profile. Typing Python, still not successful, right? What I need to do, I need to rerun a bash, and now you see that the prompt changes to base root assert, and the hope is to satisfy that when I now type Python, I see the Python prompt here, right? Hello. The hello world, we made it to the hello certificate program, our first line of Python here. So this is not what we want to use usually. We can install, for example, IPython and a few more things like, let's say, NumPy and pandas, for example. Here now on the command line. Going pretty quick, but again, this depends a little bit on your connection to the web, on the hardware, how fast it is, right? But you see here, this is all a matter of a few seconds, right? For the most important things, namely Python itself and IPython and PyPandas. When I now start IPython, you see this looks already a little bit different. Import NumPy SNP. You see syntax highlighting here. NumPy random, the legacy way of drawing random numbers, and this all seems to work, right? So that's kind of wonderful. Import pandas SPD works as well. So the most important scientific packages, or for us in finance, we could almost call it financial packages. It's not focused on that, but we use it all the time. They are there, no problem whatsoever encountered here. Right? That's about it. And when I now install JupyterLab and Matplotlib, I have my graphical user interface installed, which I was showing you before on the Quant platform, but now I'm installing it locally here in the Docker container, including Matplotlib for plotting, and I can now start JupyterLab. I need to do a few tricks here because I'm on a Linux machine and I'm running from a container, so I need to say allow root, the IP address 000, and the port given the starting of my container must be 9999 in order to be able to access this. And now this is running, and you see here a pretty long URL with a token for security reasons. And I can copy this long URL and I use here the installer page because I don't need this anymore. And like magic, this didn't take long, right? I'm now in my JupyterLab world. I can, if I prefer that, like I do these days, I can change the style here to the dark theme. This is the folder that I have created before, and I might now get started with a notebook, like import NumPy SNP, what I did before, and then maybe from PyLab import PLT style used. I'm still using it. Let me see, there have been some changes recently. Seaborn V0 _8. There was a recent update. I can't use my Seaboard anymore, therefore I need to get a new default here. And then I can create, for example, let's say random numbers. So by random, standard, normal, and maybe we go with, I'd say 250 random numbers, right? So this is drawn random numbers, but I don't want to show these random numbers. I want to rather plot the random numbers as a cumulative sum. So PLT plot a cum sum. This is then looking, I also like a random walk, right? So if I want to have this non-negative, this could be, let's say, a P&L of a trading book, but this would then end here in the negative. I could say this might be a stock price. I simply add here 100. So we start at 100, and then we have the ups and downs that we are so used to. I can redraw the random numbers, and this is what we would like to have as a long investor in the stock market, right? That the market goes up after 250 trading days from a little bit below 100 here to 130. That's what I guess something that we would all be happy with. And I want to leave this here on that positive note. My intention here was to show that really with a couple of commands that you can repeat over and over again, and this is indeed, I would say, a skill, right? Once you have this internalized, it feels like second nature, like playing the piano, like swimming, right? You might not be a world-class swimmer like Michael Phelps, but you might be able to swim, let's say, well, let's say 500 meters or 1,000 meters without problem. And this is basically what you should strive for, right? Not become maybe world class in any single area here, but this should become second nature, like a skill to set up these infrastructures. Not maybe at the very beginning, but I hope with what I have been showing, you see that it's not too involved, right? So I call this maybe demo. Too involved to set up the infrastructure with the most important things. You saw it. If I wouldn't be speaking that much about it, right? This would be a matter of 2 minutes total, I would say, right? That's how easy it is. And trust me, 10 years ago, it wasn't that easy. Things have changed, improved to the better, indeed. So let me shut this down, and we are good to go. I might leave this Jupyter Lab here, which I've set up. I have my own here running locally as well. So that's really at the core of what we do here with tools and skills. We need the infrastructure, and then you learn tool after tool, approach after approach, such as testing and version control, let's say, in order to make use of the infrastructure. Tools and skills has obviously videos in the modules. Here and there, you also have two videos, one for Windows, one for Mac and Linux, for example. I mean, that is good because there are still minor changes, although the worlds of the Windows and Linux Mac worlds, they have come quite a bit closer together, but there are still differences that you might want to take care of. So Python for financial data science, that's also, I would say, a core class which is relevant in asset management, in algo trading, in computational finance, and basically for everything else. You see here my book, The Reference Work, which covers topics such as data structures and data types, numerical computing with NumPy, data analysis with pandas, OOP, visualization, financial time series, input-output operations, performance Python, math tools, stochastics, statistics, machine learning. You see, it's not really focused and specialized in terms of finance, but let's say financial time series are relevant in every different area of finance. So this is more like a selection of topics that are important across the borders of the different specializations that you find in the program. Some of the topics you will also find, let's say, in the mathematics basics class, as well as in the Python for finance basics class, but here it usually goes a little bit more deeper, but therefore also a little bit faster through the different topics. Style is the same. You got the PDF book, you got also the text as HTML, you have the videos, you have the slides, you have the code and the Jupyter notebooks. So everything here like presented for finance with Python from the Quant platform. Python for Excel. I know this is also something of interest to many. of us here, because Excel still is one of the major tools in the financial domain, right? And this class covers very basics up until like replacing VBA by Python code, which is, I think, the real strength, right, of using Excel Wings for interfacing Python and Excel, right? That's I think it's like a pretty powerful combination. I've seen so many people when they saw for the first time what it can do with Python in the context of Excel. It's still amazing to me. So here the approach obviously is a little bit different, because, for example, we cannot do what we need to do in this class on the Quant platform, because this is run on a server within Docker containers in the browser. We need Excel to interface with Excel, and Excel primarily is like a local desktop application, although you have, of course, Office 365 these days, etc. But the full power is, I must confess, although I'm a big Mac fan, and Microsoft Office is available there as well, but the full power can only be used on a Windows platform, where you then combine what is shown in the particular class here, right? So yeah, that's the class, which is not too long, but where you get like all the necessary ingredients that you can leverage everything else that you learn in the program, almost everything else that you learn in the program, at the intersection of Python and Excel. There's one question with regard to Google Colab. There are quite a few options now. Speaking of tools, Excel, JupyterLab, IPython, etc. We have a larger number of tools these days, and one of them is Google Colab, which is basically JupyterLab hosted and largely controlled from a technological point of view by Google. I find this amazing and fantastic, in particular when you get the right URL, let's say to a Jupyter notebook which is hosted on GitHub. You can immediately execute the Jupyter notebook based on Google Colab. If you are paying for Google Colab, which you don't have to, there is a free tier. If you're paying for it, this might be running at an acceptable speed, but since speed was mentioned in the question with regard to Google Colab, from my experience, when I run Jupyter notebooks, no matter what the Python code is on my local machine, it's almost 10 times as fast as at least on the free tier of Google Colab. But I'm a big fan of Google Colab, and you will see we require these days that the final projects are hosted on GitHub and are executable without any adjustments on Google Colab. So you see, I'm a big fan, but not for everything, right? But since so far I'm not having a paid tier, a paid subscription of Google Colab, I might not be too excited about the performance, because the hardware that they provide for the free tier is for sure not as fast and cannot keep up with everything else. But if you pay enough, you get like access even to the TPUs, the tensor processing units, which might speed up your TensorFlow code by orders of magnitude. I don't want to hide this from you, or you get a different impression, but for the free tier, it is currently not keeping up performance-wise. Python for databases, of course, also an important topic, because finance these days has tons and tons of data, of course, in terms of volume, velocity, and variety, and databases, regular databases, still are important in this context, such as MySQL, SQLite, so the relational databases, or the object-oriented databases like MongoDB, or as they are called, NoSQL databases. We also cover here PyTables, which is pretty fast, or SQL Alchemy, which gives you an abstraction layer on top of quote-unquote any relational database, or bcolds, which is a columnar data store, which is pretty fast for certain applications, but it cannot be used for everything, right? So we offer you here a choice of different database options. We compare them with regard to their storage requirements, their processing speed, etc., so that you get a good feeling for what might be a good choice in terms of a database when you are faced with the need to store large amounts of data. Here also, this is something where you should have learned how to set up a cloud infrastructure, because the whole class here is set up in a way that you execute everything in a cloud instance, because we work with relatively large data files, and we set up like MySQL server infrastructure and architecture, right? So we don't want to see you messing around with your local desktop machine, and later on we are bombarded with emails saying, well, my local machine is out of storage, and I cannot start it anymore for whatever reason, right? Since I've been doing Python for databases. Therefore, we recommend, and this is the whole setup of this class, that you do this in the cloud, and you find the resources there, primarily also in the form of gists and setup scripts that you then execute after you have made your way through setting up cloud infrastructure then on such a cloud instance. Natural language processing is a pretty short class, but it provides you a glimpse at how you can work with unstructured data as well, which has become so important these days. It's at least for me still, sometimes I almost forget about the fact that numbers are only part of the financial game these days, right? There is a ton of news coming out which is relevant for financial markets, and back in the days when I was studying, started studying finance, and years before, even decades before, people were talking about news in the context of finance in a pretty abstract way, right? When you know what efficient markets are about, the basic idea about efficient markets is that once news are coming out, let's say about profit and loss, P&L, or earnings of a company, then it is assumed that the actors, the traders in the markets, the portfolio managers, the analysts, digest the news and act accordingly, adjust their position, buying, selling, do whatever they think is the appropriate action, right? But back in the days, it was not the case that the researchers were able to model in a formal way the dissemination of news into the markets. These days, this is what's happening on a large scale, that the big hedge funds, that the banks, that they are like applying, leveraging natural language processing, digesting news, and there's roughly 1.5 million news articles on a daily basis, which are processed by the large data providers such as Bloomberg, Refinitiv, and Dow Jones, right? And they digest it with the machines. They come up with sentiment scores. They do other stuff, for example, feeding what they read, quote unquote, wire the machines into machine learning models, etc. Right? And these days we have arrived at a point where we can formally model, where we have technological means to indeed implement what was just like abstract reasoning in the 70s and even 80s, right? 60s, 70s, 80s, beginning of the 90s, right? Where people say, yeah, news is coming out, people are reading the news, people are forming their opinions, and then they react based on their opinions, let's say going long or going short or do whatever. These days, that's absolute integral part of everyday financial action taking and decision making. AI in finance. I commented already that this is something that is a core part of almost everything in finance these days. So my book, AI in Finance, is dedicated to this exciting topic against the background primarily of algorithmic trading, I must say, right? And there we have in this topic area, we have two classes with 12 modules and sessions each. The one class is going pretty closely to the contents of the book, so let's say chapter by chapter almost, and the other class is going more through the details, like building deep neural networks from scratch with pure Python, right? And implementing typical algorithmic elements in deep learning. So the focus there is on deep learning, based on your own functions that you implement with pure Python. So in other words, the one class across along the lines of the book is more taking an applied perspective, and the other one is more taking an explanatory and didactical approach to it and building many algorithms and models there from scratch in Python. You will find the one class under optional studies. The book-based class here is the one that I would recommend that you follow along from the beginning, right? Then going even, if you like, one level deeper, or you can also think of it like stepping to the side, we have a dedicated class to reinforcement learning for finance, right? This is all inspired, what you see there, by the major breakthroughs of playing games like the Atari games, or the so famous story of AlphaGo, who was the first computer program, or we could say first AI, to beat the world champion in Go, which was thought of as being like a decade away, this breakthrough, when it happened, right? So here we are not going like, let's say, in an incremental fashion, getting better and better. We are going in steps, and you have seen this just recently with ChatGPT, right? Where now a Jet AI, right? A generative pre-trained transformer is able to provide you with answers to a wide range of topics, even is able to write code. And this was really, and it's still fascinating for so many people, including myself, including you as well, right? When you interact with a chat bot, we can say, but I think chat AI is, I feel, is kind of like even a better expression for that, and it can even explain you how code works, how you can implement things, etc. It's a wonderful addition, and yeah, AlphaGo was such a breakthrough. And we cover on this topic. We also go through a couple of games and how you can use reinforcement learning to master games such as Carpool, Monte-Car, and Lunar Lander. And here you see then also the examples where we have a recording of, for example, the Lunar Lander example. But this is something that you can play around with yourself. This is even a game that I was playing when I was pretty young. I'm old enough to where like the first generation of people playing these Atari games and card games back then. For one Deutschmark, it was usually back in the days per game. I was really fascinated and intrigued by all of that. And now I are fascinated by programming algorithms that master these games. So for sure, next iteration, next generation here. And the approaches that are illustrated based on these games, you see here my Lunar Lander is pretty slow. It's not the best pilot in the world, but at least this try here will end successfully. But it's very cautious. It's for sure not like a Han Solo type of space pilot, right? But it is ending this successfully. And what is illustrated here is then applied to financial applications, right? And the analogy is kind of a straightforward one. There are a couple of things that you cannot directly compare, where the application to several of the approaches that we present there might be lacking, right? Where we say, well, for example, with a game, you always have a cause and effect, right? You impact what is happening. In a financial market, as a small trader, probably you won't have an impact, let's say, on the price or whatnot. So there are a couple of problems, but I hope we highlight them thoroughly in the different classes. So Python for algo trading, one of the core topics here, based on this book, and vice versa. I explain like the feedback mechanisms between teaching classes, developing classes, and then writing books. Top of that, here it's about, of course, the foundations that we leverage to do vectorized backtesting, prediction-based trading, event-based backtesting, and then the algo trading side itself, like real-time data and streaming. One as a trading platform, which we emphasize. So Interactive Brokers over the decades wasn't able to keep up with it. I know it's so popular with many of you and many others out there, but the technology is all about what we would expect from a trading platform. The crypto world, of course, we're all aware since the debacle with FTX and some of the others before, has seen some shaky recent months, right? Even Gemini now being in the press, but this is one of the platforms that we cover. Technology probably, hopefully not influenced, but even Gemini now with some issues in the press, and more than with like success stories, obviously. So couple of platforms that we cover, but the hope is that when you have had exposure to these APIs, that if you say, but I want to use XYZ trading platform, I want to do this, I want to do that, right? That you are skilled enough to leverage what you have seen here with regard to the 4 platforms that we cover into the other platforms as well. Because if you're dealing with the REST API, it's a REST API. I think the most specific, special platform there is Interactive Brokers, which has a, I don't know, you might notice that I'm not the biggest fan of their technology. They have a wonderful product spectrum, etc. But the technology that they offer since decades is absolutely subpar, in particular if we want to do algorithmic trading the way we think it should be done in the cloud, etc. Automation and review then focuses really on putting all the elements together, doing it in the cloud, doing it in a hopefully robust and reliable fashion on, if you want to, 24/7 basis, with logging, with monitoring, maybe with real-time visualization, right? So that's here, let's say, the point of culmination where we say in algo trading. Once you have reached that point, this is really where you should end up with, that you say, well, I now have all the skills together to do this in the cloud in a robust and reliable fashion. That's really the goal here of that class, before you then enter the practice phase with practice module 1 and 2, and last but not least, the final project that you should prepare along the guidelines that we will share later on here. I think usually in 7 layers: infrastructure, financial data, the strategy, the backtesting code, the connecting code to the platforms, to the data APIs, etc., the trading code to place orders, to close positions, to do whatever is necessary to implement your strategy, and then last but not least, here on the highest level, the automation, which I was talking about before, in the cloud, with logging, with monitoring, etc. We have also what we call Wanda Masterclass. If we want to dive deeper, no real need to do so, but we have this class where we go deeper into the O&A and the Wanda. I like to call it Wanda. Some people say O&A, a platform which is also the back end of our AI machine. And I think we have deliberately chosen this particular platform because since years, many years, well, more than 10 years, they offer the best API that you can find in the space, let's say, for retail algorithmic traders. Maybe there are completely other use cases. Institutions would usually say this is nothing for us, but for retail algo traders, I would always say technology first, right? And then products, for example, second, right? The technology and the APIs that you face, this is really what makes it transparent. And I know that many people are product driven. So they say, well, I want to trade product X, Y, that, and I cannot find it on their platform. I would say yes, but what is the point if you insist on a certain product class where you don't find an appropriate technological infrastructure to properly execute your trades as a retail trader, right? Because institutional ones, they might have teams of dozens of quant technologists who take care of the infrastructure, who interact with the biggest banks in the world, right? They get like premium services from these banks because they have multi-millions of turnover on a daily basis. That's a different game. But if you as a retail trader want to do everything on your own, I would say technology first and product second. I also would say, depending on the strategy that you want to trade, it makes a huge difference, transaction cost-wise, long short-wise. So speaking of market microstructure, whether you trade, let's say, equities or FX or even options, right? It's another completely different game. So therefore, I'm convinced that for retail trade, at least to get started with, O&A, Wanda is one of the best platforms to do so. Python for computational finance. Here, the major book, Derivatives Analytics with Python. You see here one of the translations of this book as well. We cover here the market-based valuation, complete market models, risk-neutral valuation, four-year pricing, American options, a general market model which includes jumps, which includes stochastic volatility, which includes stochastic short rates, all the elements of which we are going to simulate based on Monte Carlo simulation. We show how to calibrate all these models, how to use the calibrated models for hedging, and also focus on certain different implementations. So I would say this is the most advanced class and most involved class in terms of mathematics, etc. What is behind there, right? That's really the one when you say, well, my math is a little bit rusty, you might really study the introductory parts and the other classes first before you jump into the computational finance class. The mathematical demands, for example, in let's say algo trading, are not that high. There, the demands are rather on the programming implementation side, as well as on the machine learning AI side. Listed volatility and variance derivatives has its own class, where again we cover this so important asset class. Variance, including all the Python code, including the details with regard to volatility indices, how they're calculated. There's also code which does the calculation, so to say, the recalculation of the VSTOXX index, and the methodology of the VIX index in the US is basically the same, right? But we have been doing in the past a project with our European, with the Frankfurt Eurex derivatives exchange, and there is obviously the VSTOXX and the Eurostoxx 50. But what is shown here applies to the US market, VIX options, VIX futures in the same way. It's just a different market, but the methodology and the topics, the models are the same. We also cover in detail our own open source pricing library, DX Analytics. This goes in parallel to the let's say foundational classes in computational finance. So you can do this in parallel, or you can, for example, focus first on the foundation class and then do the DX Analytics modules as you see them here: framework, model simulation, a ton about portfolios in this context, American valuation, also Fourier pricing, multi-risk derivatives, etc. So here we even cover more advanced and more involved topics which haven't been covered in the book or in the class before. Therefore, either you do it in parallel, because this is really like an applied perspective here, or you say, well, let me first fully understand the basics of all of that, and then I go into the application side here with DX Analytics. You also will see charts like these which explain the architecture and methodology behind DX Analytics, because it's completely Monte Carlo based with a non-redundant modeling approach, which means we have orthogonal classes, objects which interact with each other and allow for a consistent modeling of your portfolio or of your valuation problem at hand, even to the point of multi-risk derivatives like basket options, or portfolios composed of different derivatives, maybe written on similar or shared set of risk factors, etc. So this is all explained in that class. Here, 8 layers that I think of. It's infrastructure, financial data, that's the same. Then we have the models, the simulation of the models, Fourier pricing for the calibration of the model. Then we have the market valuation, meaning the valuation based on models in line with market reality, with market prices, and the hedging of other derivatives based on market calibrated models in that case. Last but not least, Python for asset management. Here we review the basics of risk and return in finance. We then dive into the traditional mean variance portfolio theory. We cover capital market theories such as the capital asset pricing model and arbitrage pricing theory. Also alternatives to the mean variance portfolio theory such as risk budgeting and parity. We then turn our attention to AI and machine learning for asset management, where we also introduced the Black-Litterman model, which allows us to include views, meaning predictions from machine learning models, into the asset management process. And we also compare the performance of the different models in different contexts over time, for example, with rolling back tests, etc. So that's also a class which has more than, I'm not sure what, close to around 20 different modules there, right? And here you see the one of the major charts, obviously, is the bullet, the MVP bullet in the chart, the lower right-hand side. This is really from traditional mean variance portfolio theory to AI for asset management. This is what this class is about. And when you think of it, algorithmic trading is, I like to say, a multi-billion-dollar area, and asset management is obviously a multi-trillion-dollar area, right? So from the point of importance, asset management overall, for sure, more important. But I know for many of you, like myself as well, algorithmic trading, maybe a bit smaller in terms of the sub-industry, sub-sector size, is sometimes even a bit more exciting, because it's also a matter of like the time span, the time horizon, right? In asset management, you usually have a horizon of, let's say, 3 months, a quarter, half a year, or sometimes even 5-10 years, right? And in algorithmic trading, it's maybe on a daily basis, or even intraday, where you go like on the hourly level, or minute bars, or even on the sub-minute level in the algorithmic trading area. Therefore, it's a little bit faster, is my feeling, and therefore for some it might be a bit more exciting. Here you see the theory. It's the first pages of, or some of the pages of the traditional paper 1952 by Harry Markowitz, which later on brought him the Nobel Prize in Economics, which is not really a Nobel Prize, but something along the lines of the prize by Alfred Nobel. The major resources here on the left-hand side, the book that I recommend, it's not only about risk parity and budgeting, but I think for me it's one of the best, most comprehensive and well-written, best-written books about portfolio management by Thierry Roncalli. It covers obviously risk parity and budgeting, but it also covers in absolute detail the traditional mean variance portfolio theory. When you then add Python for Finance and AI in finance to the mix, you have all the ingredients together to follow along this class. Now, a quick look at a few more case studies. I've covered Quant Platform, check. I have shown how to set up Python with Docker, check. So we now have crypto basics, efficient markets, model calibration, market prediction on the trading platform and NLP. You find the resources here under this link. So bit.ly, short link, then cert_intro. That's the gist here, right? And here the first Jupyter notebook is about crypto basics that you find here, and then it goes to the other ones like efficient markets, etc. Right? So this is all provided here in this gist. Yeah, let me get started with the crypto basics, and one of my favorite topics, although I'm not using it in a practical manner, is the use of Hashcat for password cracking. Cracking would be the, let's say, the black word, and password recovery would be the white version of that. Hashing is an absolute fundamental concept in the crypto world, and hashes are not only used for cryptocurrencies or crypto in general. This is used, for example, to store passwords in a database, because the major characteristics of a hash function like SHA-256 is that it is pretty easy and straightforward once you have an appropriate implementation in the form of the code, right? To take whatever the input is, let's say a text file, right, or a password in this context, and generate a hash out of it. The opposite, having a hash available, let's say in the database, and reverse engineering the process, trying to figure out what was the input to the hash, this is what is difficult. It should be, quote unquote, impossible with available compute power that you can reverse that process, right? But this is the theory, and in practice it is the case. But you might have heard about the major promises of, let's say, quantum technology, and once major breakthroughs are reached there, then what we these days use in terms of hashing functions and encryption technology might not be as safe anymore as before. So Hashcat is the tool of choice that I use here, right? And it's according to their own marketing, probably it is. I would trust them. It's the world's fastest password cracker. Let's say we say password recovery solutions. Right here, I show you how to install it, depending on different approaches. And now we are going for a simple mask attack. So I import hashlib here, and let's say I use my first name to generate a hash. You see, I've inputted Eve just 4 characters, and I get a pretty long hash code here, right? You can always check that here by length of SHA, so 64 characters of hexadecimal for a hexadecimal number. This is what a hash code is. And I think you might see already that we would have a hard time to judge from this output what the input was, right? So I can repeat this, and this is not a random procedure. This is really like a deterministic procedure. I can repeat it 10 times, and it would always give me the same output, which is another characteristic of a hash function. There's nothing random there, right? I can now input Eve2, 1 more character and the number now, and I get another one. And the same holds true. So here it's deterministic. And when I now write these 2 hashes to disk, right, to hashes text, takes a little while. Let me click on this again. You see now there is a file hashes text and the 2 hash codes, hashes, hash codes, hash numbers, it's the same. I use them and many others use them synonymously. So they are now written on disk, and I can look it up here as well. And I remove here a POT file which might have stored previous password recovery operations. Now what I'm going to do is I try to recover the original inputs here, meaning the potential passwords from the hashes. This is what is called password cracking or password recovery. And they go here with a certain mask and a number of commands here for Hashcat. Nothing that we should care about now. Maybe one thing that I should highlight here, you see I only allow for lowercase characters and for digits, right? And let's go. So it starts now recovering. First, it's a typical output, what it tells us, what are the how it is set up. Here it now starts going from 1 character to 2 characters. Here you see to 3 characters. This was the increment flag to 4 characters, and here is 1. The first it's already the second. I missed that one. Here is the first password that it has recovered. Right here is the second password, and it is done. So when I now use the show flag, it shows me the 2 passwords. So this was really now reverse engineered, and it works based on brute force. So I say only lower digits and lower characters and digits, and it tries out every combination. So it's just a matter of brute force. And trust me, this is pretty similar to what I'm doing here to the process of Bitcoin mining. It's similar. It's not the same, but it's similar. It's simply a brute force operation. That's the reason why I don't like when the popular press says that, yeah, Bitcoin mining is about solving complex mathematical puzzles. It's not complex. It's just that you need enormous compute power in order to solve the puzzle, but which is by no means mathematical, right? It's simply do a brute force operation, and you might be lucky earlier or later, right? So now random hash codes. Let's generate some beyond my first name, which is pretty simple and short. Let's, based on lowercase characters and digits, let's generate passwords from length 4 to 6 characters. Now I have created a set of random passwords. Although they are pretty short, I think they are not easy to remember. 14D5CA, of course. I mean, if you type them a bunch of times, you probably remember them easily, but these are now not related to first names or whatever, birth dates or whatnot. So I'm writing these passwords now in a hashed manner. You see here, I use the MD5 hash code to the file from before, and here are the hashes, right? So these are the hashed versions of my random passwords, and I now do the same operation, right? I let Hashcat crack the passwords, the random password. So it might take a while since I go like in increment fashion. And here you see with the 4 characters, it was already successful. Like 6 of them have been 4 characters. There is another one with 5 characters. And here 1, 2, 3 with 6 characters. And after 12.5 seconds, we get now the hash code plus the password, the random password, which was used to generate the hash code, right? So this is what we get. This is how it works. And now I let it run. This might take a little while. Let's now come up with something highly sophisticated, meaning we are using lowercase, uppercase digits, and also special characters, right? This now looks quite different, right? This might look like Tesla even here, just by chance. And this will now take quite a long time, right? So I simply let it run now. And trust me, on my M1, it's not the fastest thing here on my Mac M1. It's not the fastest. It is already kind of fast. Let me see how fast it is. You see here, it is going at this stage at a rate of 33,270 kilo hashes per second. That's fast, but that's not really fast when you compare this, for example, with a GPU-based approach, which Hashcat can do as well. While this is running, we don't need to wait. I can move on towards efficient markets. Why are efficient markets so important in finance? Yeah, I don't want to argue about the overall importance of efficient markets beyond the fact that this is a theory, that this is a hypothesis which has seen tremendous support in the econometric literature over the decades, right? It simply says that any type of analysis of historical data shouldn't bring any economic benefits when you want to leverage the insights. For us in the program, the importance is twofold. Basically, in the computational finance class, we use efficient markets to calibrate the models by saying that the market is always right. We use as input option prices and calibrate the parameters in the models to the market prices. So we make use of efficient markets as our, let's say, a lever to come up with market consistent models. So there we take the position of, markets are efficient, at least we hope so. And when they are efficient, we can implement the following procedure. In the asset management class, it's basically the same. We take the statistical characteristics, the prices, etc., of the assets that we are interested in, of our asset universe as given, and we form portfolios according to certain rules, like mean variance or risk parity, risk budgeting, etc. Only when we then enter the world of predicting future returns and trying to use historical information, historical data to predict something that lies in the future, then we try to beat the market and try to show, in a certain sense, that markets might not be as efficient after all. And in algorithmic trading, this is really at the core of what we do, right? If we would fully agree that markets are efficient all the time, then we wouldn't even try to do algorithmic trading based on certain trading rules, statistics, technical indicators, or machine learning, deep learning, reinforcement learning models, right? In this area, indeed, we try to get an edge by, sometimes simple, sometimes highly sophisticated prediction models, which hopefully give us an edge which materializes in a market outperformance after transaction costs, etc. Right? So, having said that, let me quickly check here whether this has finished. And indeed, it has finished after 3 minutes and 16 seconds. You see, this took quite a long while because we are now allowing for such a large character space. But anyways, after 3 minutes and 16 seconds, we have reached the point where all the 5 have been recovered. And here you see this was running at the end with about 36,000 kilo hashes. Right? That's kind of like the speed achievable here on my machine. With GPUs, this would be much faster, even in particular when you have a large GPU machine. Right? So interesting aspect from the crypto area, but not directly related necessarily to cryptocurrencies, right? But I mentioned already that the process of Bitcoin mining is different, but in a certain sense similar. All right, now let's have a look at our data that we have here. This is a data set that we use for certain classes. We have here Apple, Microsoft, and a few more. Here see more details, and we can calculate, for example, for all the symbols that you see there, like the S&P 500, the VIX volatility index, we can calculate in vectorized fashion the returns. These are daily log returns. Now let's do a little bit of plotting here. I plot in normalized fashion here the different elements. There's also some Bitcoin in there. When I turn off the Bitcoin, we see this a little bit better, right? But I can turn it on, for example, or I have a look at the returns here as a histogram, or for example, at a correlation heat map, right? Here we see, obviously, on the diagonal, we have the perfect correlation of 1, because every asset is perfectly correlated with itself. No big surprise. And the lighter it is, the lighter the color, the less the correlation. And you see here for the VIX volatility index, we have basically the lowest correlation. So now we prepare a couple of legs in the spirit of, let's say, when I open this trade, let me open one the trading app. What I now want to do is to mimic what traders do in the market. So it's loading the data, right? And we see here current market data where traders look, oh, well, the current price is that, and let's have a look at the history here, right? Let's say we have these two simple moving averages, 9 and 25. There's a crossover here, so we would go along, right? So we have a look at the history of our bar chart. So here's Heikin Ashi bar charts, right? And given the history that we observe in the chart, we directly or implicitly predict the future. Here it is for Euro US dollar. Here is a chart for Brent crude oil, BCO, and we might have here different indicators that we have a look at, right? And say, well, given what I see, whatever it is, I use indicators, I use support lines, whatever other indicators. I say the market goes up, the market goes down, and therefore I go long or short accordingly. So having a look at the history in order to predict the future of the market. And this is the technical approach that I want to implement here. I take my price data and take 7 historical closing prices. I go with 7 historical lags, right? So when I have a look at the data, you see here that's today price, that's yesterday price, the day from the price from the day before. So I use 7 historical lags in order to predict the next day's price, right? And when I use this for a regression, I have an econometric approach, so to say, for what traders do in the markets, right? They know the current price, yesterday's, or depending on whether it's hourly bars, minute bars, or whatever, right? So we go back in time 1 bar, 5 bars, 7 bars, 70 bars, whatever the number is. So here I go with 7 bars. Do the regression here, ordinary squares regression, 7 historical lags, my dependent variable, today's price, right? And I get my regression parameters. And here I combine the regression results, and you see that I get an average which is close to 1 for the first lag and close to 0 for all the other lags. And here I jumped over that in the beginning, but efficient markets in a simple case can be interpreted that the best predictor of tomorrow's price, if markets are efficient, if the market follows, for example, a random walk, then in a least square sense, the best predictor of tomorrow's price is today's stock price. And this is basically what we get here from this simplistic ordinary squares regression, that we say, yeah, we need just lag 1 in order to predict next day's price, because this is the best predictor that we can come up with. It's close to 1 and the rest is close to unimportant. And when we then do a plotting, we see this visualized over all the instruments, right? Only lag 1 here has a high weight, sometimes close, really close to 1, sometimes a little bit lower, right? This varies over time and over the single assets. We can then have a look at the mean values. For the mean values, the same holds true, right? But we need to be aware of that, even if this might look like a pretty nice illustration of efficient markets, because we can show like that the best predictor for tomorrow's price is today's price in a numerical fashion. We are violating one of the major assumptions here, namely that the lags are basically all perfectly correlated. So in other words, lag 2, 3, 4, 5, 6, 7, they don't add that much information, maybe no information whatsoever to what lag 1 is already offering. We are also violating another assumption, which is that for such time series data, the data should be stationary, and we are dealing here usually with non-stationary data. But it's kind of like a starting point where we then dive in several areas much more deeply. If you want to get more information, you can work with stats models, for example. And with stats models, you get here for BTC, for example, R squared, adjusted R squared, the model is OLS. You get for every single lag here the different statistics like the coefficients, right? 1 and the rest almost 0. The standard error T statistics only significant here for lag 1. The p-values all too high for lag 2 to 7, and the intervals plus a few more statistics there, just to show that NumPy and the standard packages are there for sure. They are good, but we got more tools, and depending on the use case, more detailed and sophisticated tools than the standard one. So having said that, this is basically the starting point and an important concept for both computational finance as well as on the other side, or at the intersection asset management, and on the real other side, algo trading. Let's first make use of efficient markets as our friend for the calibration of an option pricing model, and this is explained in detail in the book and in the computational finance class, based on the Merton jump diffusion model. And again, it's not here a teaching session, it's just to whet your appetite. You see here the model in mathematical terms with a brief description of the variables, and here the implementation of the characteristic function for that model, of the integration function, then for the integral. This is a Fourier-based pricing. You have heard Fourier option pricing a few times. Now a numerical example, and these three functions taken together, they allow us to value options in the context of a jump diffusion. And now I use the same valuation function to work with market prices of liquidly traded options and to come up with parameters sigma, lambda, mu, and delta for my model, so that the model, as good as possible, replicates the prices of the options as seen in the markets. So I work here with options data. I have a couple of standard inputs here, right, from the market or assumed. The options as selected are the following. We have here put and calls. I work with the calls here with the call prices for a certain majority for different strike prices, right? And I can plot these. These are the option prices as plotted against the strikes, right? The lower the strike price here, the higher the price of the call option. The higher the strike price, the lower the price of the call option. So this is what we see here. Now we define an error function, which we want to minimize based on our procedure. And this is done first by brute force or global optimization. And secondly, by a local optimization, which starts at the best parameter combination as found by the global optimization approach. So I like to use the analogy of Superman flying pretty high in the sky and then noticing that there is some help needed down there, and he scans the surface, right, of the earth, and he spots something, and where he spots something where his help is needed, he goes down to the location and checks further. And this is what is happening here. First, we have a global look at all the possible parameter combinations, not like all the possible, but for a wide range of possible parameter combinations. And then we drill it down where we think this might be the place where we find the local optimum, right? So this next procedure, local convex optimization, starts with the previous optimal one. And you see the mean square, the root mean squared error was 0.97, and the local one is able to get the root mean squared error further down to 0.767, right? This is the additional improvement. Now we compare the market prices with the model prices, and if we just see the upper part of this chart, this looks almost perfect, right? The model gives us the red dots, and the blue line represents the market prices. If we have a closer look here at the differences, we see that there are differences on the left-hand side, like +1 euro, here -1.5 euro. But we see that the differences are unbiased, meaning we have positive as well as negative derivations. And this is something that, how shall I say, that we would expect in any case. So the models, the parsimonious parametric models, are usually not able to perfectly recover the prices. But again, this is an exercise in numerical optimization. So we wouldn't expect all the differences to be zero. This doesn't work. Our degrees of freedom are simply too low here, but we try our best. We minimize the root mean squared error, and this is the result that we get there. So all based on the assumption that markets are efficient, that the prices that we observe for options, vanilla options in the markets are the right ones. So we wouldn't argue about the single prices for these options that we observe. Okay. So that was the third one. Now, the opposite, the complete opposite, where we use financial features and machine learning models and try to outperform the market, right? We work here in this context with different data, a different data set, and that's a data set here which is intraday, right? See here also on the euro US dollar, that's for one instrument only, open, high, low, close, and it's intraday data, half an hour, right? And then we generate financial features here, like returns, like market direction, the difference between close and opening, the difference between high and low. I'm just picking out some rolling volatility, momentum, simple moving average. So we are basically free here in what we choose. Hopefully there is some structured research process which let us come up with these features. But from an application machine learning point of view, we have the features, we use them, we lag them here, right? Do some lagging and normalization. Takes a few seconds because we are dealing now with 210 features, like 21 different features plus 10 lags for each feature, right? Similar to our efficient market analysis. And then we use, for example, a deep neural network and fit our model with regard to the market direction based on our 210 features. We could, if we like, do what is called feature selection. We have different methods for that. There was just one question in the user forum yesterday about this topic. But I go with the 210. Deep neural networks are pretty good at their own selection, so to say. Here I do the prediction now based on the test data set, and I do the back testing. You see here for the period that we test the passive benchmark investment has lost some 3.3%, and the strategy here gains some 4.8%. So it makes for a 7 point something outperformance, close to 8%. We have 566 trades. And when I show the trading strategy as compared to the market strategy, you see the strategy or the market passive investment is not a strategy. You see the green line representing the trading strategy without transaction costs whatsoever, and the blue one is the Euro-US dollar passive benchmark investment over a couple of months here in this context. So here I'm not saying that this is the way to go. I'm just saying this is the opposite to leveraging efficient markets, for example, to market-based calibration of financial models for option pricing in our previous case. Here we try to use derived statistics from historical price data and returns data to outperform the market by generating our own predictions. Just on a day by day or bar by bar, half an hour by half an hour basis, right? No matter what it is, it can be 1 minute bars, 5 minute bars, 1 hour bars, whatever it is, the approach will be similar. And we try to leverage information based on machine learning models here. It's a deep neural network that we use in order to predict the future market. And it's here on the test data set and not in sample. This is really out of sample. The model hasn't seen the data before. It shows no performance, but it is safe to say that when we would factor in 566 trades with the respective transaction costs, probably the outperformance here would vanish. Therefore, economic profits are something else than a statistical edge that you might discover, right? So for the calculation of an economic profit, we would need to do a more proper backtest, including the relevant market microstructure elements. But let's say now we have discovered a strategy that we would like to implement. Then we can, for example, turn to 1.1a. The data that I was showing before here was retrieved from this platform, right? And let's say we have done our homework and we have come up with the strategy that we would like to implement. Then we can turn to the platform and connect to the API based on credentials. Here I have my test account credentials. Their paper trading or test account is fully functional, right? And I can retrieve, for example, data for Bitcoin denominated in US dollar, right? Here for the particular period that I'm testing, right? You see simply the evolution over time there, right? That's yeah, I was retrieving from the 1st of November to the 3rd of November, right? 1 minute bars. I could go to also here in 1 year to something like not at the beginning. Oh, we don't need to go that far back. Maybe we go with 04 and here 07, let's say. All right, we're getting now more recent data. Of course, fully flexible, and for basically all the instruments that are traded on this platform, you get the data as far back as the instrument was traded. So let's say an instrument is available since 15 years, you get here 15 years worth of historical data, down to the 5-second bar level, not on the tick data level, but 5-second bars. This is what you can get: hourly bars, 1 minute, 5 minute bars, etc. Right? Let's now say we would have a momentum strategy that we want to backtest there. I'm not going into the details, right? We can calculate a hit ratio here, and we get like more falses than trues, right? The hit ratio is not perfect, but this is just why, I mean, I wouldn't expect anything perfect, but it's not good because it's below 50%. But let's do the vectorized backtesting as we have done so before. And you see here this simple strategy, which I've now implemented based on the data that I've just retrieved. I haven't done any adjustment, but I could try now. This is not, don't get me wrong, this is not research, but I could go now here with 7, for example, instead of 8 for my momentum. This might improve things or not, I don't know, right? But we see at least some slightly different results. But the momentum strategy here for the on Bitcoin doesn't seem to work too well, at least on the granularity that we have. And yeah, that's the one thing. But maybe let's go, since we're on 1 minute bar, maybe let's go on a 60 minute for 1 hour, just as a final check there. Right now, still not. It's improving the ratio. It's improving, but it's not getting better. So maybe we would need to adjust the momentum further, right? It's just an idea there, but I'm not here in the business of selling you good strategies at this point. But what I want to show you, and what my business is that I'm selling, is how to execute orders based on potential signals. Right here, I'm not using Bitcoin, it's BCO, it's Brent crude oil, 100 units. Let me check. Here, this is, you see now, it took a little bit. There are 100 units long. That's the margin that is used. That's the price at which I enter the position. The current price, my profit is slightly negative because they immediately deduct bid-ask spread, the half spread there, right? And here my profits in pips, the profit in percent. It has turned now a tiny little profit. You see here, this also indicated in real time. So this is now an order that was placed based on the code that I executed, right? When I now reduce the position, create order units minus 50, right? Let us check. Indeed, here, number of units 50. So we have reduced our position. We might have realized a little profit or a little loss. I could check now in the overview. But if I want to close now the position completely, I would sell the remaining 50 units, right? Here, meaning that in the overview, my position has vanished, right? So what I would do here, let's say with a right click, where I say buy, or here, even more here, you see, right? Buy, sell. This will be one thing, or I can buy, sell here, right? Either with a right click, trading, buy, sell, right? Or I go here to sell, for example, and then I need to click submit, or I place take profit or stop loss. I can do all of that here based on the code. And of course, usually I wouldn't do this here based on entering a position manually with the code, right? That's not what I would usually do. This would be triggered by an algorithmic trading program which generates a signal and then executes the appropriate order. So I'm having here a bunch of orders executed in the past, and I can look up, for example, for my recent trades, I can look up all the relevant information like the P&L. You see I've made here a tiny profit of 1.8 in currency amount, right? This was my last trade here, minus 50. The half spread cost was subtracted, and yeah, you see basically all the information that is coming in here. And that might be relevant, sometimes it might not be relevant to your trading strategy, right? And in order to do algorithmic trading, we also need to be able to process real-time data. And this is what you see here. Now I'm streaming again Bitcoin prices, here bid-ask spreads, just the 20 of them. Of course, I can execute this again. We get 20 more, the bid-ask spreads here, which you see is in real time. This is GMT time, which is 1 hour before us here on the European continent, here where I am in Germany. So that's not, in other words, historical data given my clock here. That's at the very same time, but the times that you get here from the streaming API is GMT time. Yeah, that's what you need in order to then do the algo trading, right? You need a strategy that makes sense, meaning you get a positive economic backtest, and you trust in the reasoning and in the robustness and stability of the strategy, or in other words, in the opportunity that you have discovered. And then you have here the technical means, retrieving data, placing orders, streaming data, etc., in order to make use of your discovered strategy to generate economic profits. No guarantees whatsoever, we all know that, but these are at least the technological ingredients that you need to do that. So last but not least, I was talking about the processing of text instead of just numbers. And here a very simple example where I use NLP techniques here, just based on one of our static pages. I can retrieve easily such a web page if it's publicly available, and you see there is a ton of technical stuff in it, which is usually for us human beings completely irrelevant. This is only relevant for the browser to render the web page appropriately, right? This has 219 Ks roughly of contents, HTML, JavaScript, and text. So when I process the text based on my little NLP helper function, clean up HTML, the whole text boils down to 9,100 characters only. That's, let's say, the human readable content. And suddenly you see that there are words and sentences that we all understand, right? Power asset management, algo trading, Discord server successfully complete, etc. Right? This is all what we understand and what we would be interested in if you would like to analyze this page. We can then generate tokens, which is like a vocabulary, Jupyter Learning, instructional instructions, right? We can create keywords out of that, but jumping through them, for example, here, what I like are word clouds. They are often used these days to visualize text and the frequency and importance of words in a text, like algorithmic, training Python, session, self-finance package. And this is just for a static page. This page changes maybe, I don't know, every other week, let's say. But let's try the same thing with a different page, namely finance.yahoo.com, right? So when I copy this and paste it, finance@yahoo.com, you know, probably that's a financial news page. Macy's quietly lays an egg, Republican Kevin McCarthy, Elon Musk, sustainability, Bill Gates. So there's like general news, financial news here, like stock prices, gainers and losers, and quite a bit more. So this is publicly available, accessible. So I can download this page as well. So here, request get URL text, and I have the technical form here. Still, a ton of things that are not really interesting and relevant for us because it's not really the content. Here, free stock quotes, up-to-date news. This is something that we can read, but overall, this has some 1 megabyte worth of text. And when we clean it up, just 1,000 characters remain. And what remains is then again something that we can read, right? It's not perfect. You see, it puts together a couple of words, maybe here and there. That's not perfect. So we can again create a vocabulary, which we can use for other things, or keywords in this context. Another way of creating keywords like business change retail, maybe a little bit too short, but 35 words here from the word cloud. We see here finance, tax, income, corporation, stock, retire, price change, retail, market, advertisement. M is kind of like an HTML keyword. Probably this would need to be sorted out as well. So the HTML cleanup is not correct. Maybe we go with 55 here in this context, and we get maybe a better overview, at least a more detailed overview here of what is going on, like stocks, change, stock, commerce, tax year, Alibaba, small. I would have expected some Elon maybe mentioned here. But I think you get it. And this is just indeed scratching the surface, right? This is scratching the surface. This is just a starting point. And I wanted to show that, of course, the World Wide Web is full of text, right? Think again of ChatGPT. This is like the source, the resource for training such large language models, LLMs, right? And we can kind of process this easily. So just a few helper functions, and we can clean up any web page and get to the gist of the text, etc. This works with PDF files and other stuff as well, right? So NLP also a part, I wouldn't say, or they're saying that's a core part of our program, but at least you get their input and tools as well, and in particular reusable functions like the one that I used in order to be able to cope with unstructured data, meaning in the form of text. Yeah, let me maybe shut down all of my Jupyter notebooks here and close the Yahoo Finance part. Again, you find all the resources here in the gist as indicated here. So, study plans is a wealth of information, a ton of classes, a ton of things that you can study, and the study plan should be your guide. The study plan doesn't include everything. Here in the 4 months or 16-week study plan, you do not find, for example, the basics classes. Again, they are not replacing one or the other of the classes that you see here. They are complementary, and if time allows, you should study them on the side. Even here, you see there is the column with the optional resources. I consider Python for Excel optional because not everybody is working with Excel. But if you think that's important to you, you can start it at the beginning with Python for Excel. But you should focus here on the first 3 columns. Later on, you should, I usually recommend, decide for one of the 3 core classes. That's already enough from experience, and maybe later on dive deeper into the other core classes. You should follow along tools and skills, financial data science, and AI in finance. So that's kind of like what you should do. So overall, you might have 1 or 2 modules in the core part, then 1 session in general for the tools and skills class, 1 in financial data science, and 1 in AI in finance. That's already quite a bit. If time allows, study the basics classes, study here the optional resources that are listed there. If you want to study self-paced, you have the other plan here. This is the 1-year study plan, which is structured into 3 12-week trimesters, as we call them, where you might get started with asset management. I think that's a good starting point. You then move on towards algo trading and then computational finance. And you also see the math basics and the crypto basics class listed here. Python for Finance Basics is not even listed here because it's new. I don't want to overcrowd. You see, we have so many resources these days that I think listing them all might rather be threatening than helping. I know that you know best about your resources, your time that you can allocate to study the program, right? Therefore, you have the options. You can, of course, design your own program. Just if you want to follow the live sessions, of course, you can do that, but you can still tailor your study plan around what you see here listed, right? 4 major guiding principles should be mentioned here. The first is that it is a Python program, right? Sometimes people say, well, now, Yves, what is the trading strategy that you would recommend to be implemented? I said, well, we don't provide investment advice, nor are we in the business of selling any kind of strategy. We show you the technological ingredients and teach you the respective skills in order to empower you to do your research and the implementation of your strategies, to stick to this example. So it's Python, it's not primarily finance. Finance is our background. We teach a ton of finance, but in case of doubt, it's Python first and finance second. Specific, all the algorithms that we use and the examples that we show are specific in nature and not meant to provide an exhaustive overview. Right? They are really focused and sometimes pretty narrow, and this, I guess, for good reason. Right? Therefore, it's not that we say, well, we show you 3 things, but there are 30 others, and the 30 other things that we could show are the following. Right? This is usually not our approach, that we try to be as exhaustive as possible. The third principle is reproducibility. So quite a while back, we have changed basically all the examples to static data sets and not to APIs that might change over time, or data sources that change their setup or that vanish or that suddenly become paid only, right? Therefore, the code and the static data sets together should make it possible for you to reproduce the results that you see in the sessions, videos, and in the code examples and the notebooks. Last but not least, you should consider the program not as a theoretical exercise, nor as a movie that you watch for your pleasure in the movies, right, in the cinema. It's rather practical in the sense of that when you take lessons to learn how to play the piano, you are supposed to play the piano from the very first session. And this is how you should approach our program, Python for Finance, as well. Or if you rather prefer, how when you back in the days learned how to swim, right? You were supposed from the first day on to jump into the water and to make your moves, right? And this is with coding as well. Just watching the videos and following along the code, this is not the best way to learn the skill. This is a starting point, but then you should, in order to acquire coding and other practical skills, you should do it. You need to do it, not you should, you must do it, I can say. Skill acquisition is indispensable, right? And I show here this fantastic book, Peak Secrets from the New Science of Expertise. I can only recommend this book. It's a book I've read it, I've listened to it twice as an audiobook. It is about deliberate practice and how to improve skills to world-class level, to world-class performance. You don't need to strive for world-class performance in all the areas, but you need to strive to performance level that empowers you to do what you want to do on a daily basis in an efficient way. And this requires you to sit down, put your fingers on the keyboard and start coding, right? Replicating what you have seen, doing the exercises, solving your own problems, etc. pp. Speaking of the exercises, you will get access to review questions every 3 weeks, which usually marks a milestone in the program. So 12 weeks, every 3 weeks, you get like a set of review questions. They are like general and sometimes a bit more abstract in nature. So not about coding itself, but these questions should help you learning about yourself and learning about what you have learned previously. If you have fully understood what was covered in the program in the different classes, or maybe you might discover here also places and topics which you might want to review, right? If there are a couple of guys say, oh, I'm not sure about the answer to this particular question, let me review that part. So I do like, I don't know, maybe you do a check behind it, and cross behind the questions that you can answer securely. That's what it's meant to be, just for you to sit down maybe for an hour and review the questions and think of what you have learned and discover maybe spots where you need to polish your understanding and polish your skills in that area. And then you have the tutorials. This is really practical where you are supposed to code. They might be pretty simple and pretty close to what was covered in the program, usually in the core modules, not in the optional ones or the additional ones, right? In the core ones, simple exercises close to the things covered, exercises a little bit further away where you need to do a transfer, or something that might be completely independent or which hasn't been covered that way in the program. We usually call these test projects. They're not large projects, but yeah, this is more like not a simple exercise with a few lines of code. It might be that you sit down for a little bit longer and come up with a complete solution, which involves a couple of elements that you need to put together. Of course, 24/7 you have access to the user forum. I've shown it on the platform, so please make use of it for all technical and content questions, right? And please make sure that when you post something that you post according to the rules. Just today or yesterday evening, there was like a question. Hello, in the book, the code has as a result 3.5. When I execute the code, the result is minus 0.6. Can you please explain? Yeah, without seeing the code, without having a fully executable code base in the form of a Jupyter Notebook or a Python script available, we hardly ever can answer anything related to such a question, right? So please make sure when you start a new forum post, you are prompted and you need to confirm that you obey to the rules of the user forum. I'm emphasizing this because this is happening all the time. And probably if I would be stuck with a problem, I would also go to the user forum. I got this problem. Anybody out there help? So, but one step back, think of what a problem is, think of the minimal but complete executable example that you can post, for example, in the form of a Jupyter Notebook, which reproduces your problem. Otherwise, yeah, I'm honest, don't expect an appropriate or even helpful answer in due time. Because these are the rules for coding. If you say, for example, that's like my favorite and one of the standards, I've done exactly the same as you have been doing in module XYZ, but I'm getting a different result. How can this be? Whenever I hear I've done exactly the same, I'm almost sure that's probably not the case, because otherwise, for most of the examples, then the output would be the same, right? There are, of course, some examples where you have, let's say, random numbers that are drawn, right? Then you can get different values, for example. But the majority of the examples, if you're doing exactly the same, then you should get most of the time exactly the same output. The Discord server is for everything else. So if you have an organizational question, let's say, when, I don't know, what about, this is a typical one. So I was thinking of something that is usually a question here. It's about the final project. Don't think about the final project now. You have enough time. Just focus on the program. Once you finish the 12 weeks and the practice phase, then you can think thoroughly about the final project, right? Therefore, here, since I've just seen this, there are questions about the final project. This is something that we can discuss here because it's not really content related, it's more organizational, or it has an administrative twist, etc. Or you have a question about career advice, or you want to connect to other delegates in the program. This is really the Discord server, what it is meant to be for, right? Log in, post it, and share it with the world, the TPQ Discord server world, and we can discuss anything else beyond content and programming question, which the user forum is for. This is here the place for all the other topics. That's the Discord server. This now is my final slide. Again, I repeat myself, I'm pretty excited to get started here. New year 2023 January cohort with again new things on the horizon that we're going to add to the program, which has grown tremendously. I'm happy to say over the recent years. Also, the group of delegates has been growing thankfully over the years. So happy that you entrust us with a little bit of Python for finance, skill improvement, hopefully to brown belt or even black belt level in the near future. I'm really looking forward for the next 12 to 16 intensive weeks, 12 weeks of formal education informal program, and then the 4 additional weeks that come after that. I hope you are similarly excited. If you have questions, again, technical ones, programming ones, user forum, anything else in the Discord server, if it is something, of course, that you don't want to share with the general public, which is a personal question, feel free to reach out by email. But for, I would say, 98% of the questions you might have, use the user forum and the Discord server, and make the best use of all the resources and of us that you can get of it. In that sense, I wish you a happy Python for Finance learning and coding and skill acquisition. I see you in the next session. Take care. Bye-bye.